Hello everyone. Today we're going to be solving the UniqueNFT Ethernaut challenge. This is a very nice challenge that we'll have to do with account delegation using EIP7702 as well as reentrancy. So let's take a look. So we're told that we are welcome to the UniqueNFT where any user can get their own shiny digital badge. We are also told that if you are an externally owned account, you can mint for free. But smart contracts have to pay a toll. We're also told that we cannot trade these tokens, and we can only have one badge per address. And basically, the goal is to outsmart the rules and own more than one single NFT. So let's take a look at the contract. So we have just the unique NFT being in ERC721. We have the mint NFT smart contract, which requires us to send one Ether. So we're not particularly interested in this one, but we have the external function mint NFT for EOAs, and we require that the originator of the transaction is message.sender, and if that's the case, we're going to mint the NFT here, and we're going to call this function. We're going to require that our sender is not already the owner of an NFT. Then we're going to increment the token ID, and then we will call this strange function that we'll take a look at later on. And then we'll mint our NFT and we'll return the token ID. And the update function here, we see that we require the from to be address 0 or the 0 address. And with this, the token prevents us from trading. So you can never trade by requiring from to be address 0, but you can mint. So we're allowed to mint, but trading is not allowed. So let's actually go ahead and paste this into Remix. So I'm going to open a Remix window, and we're going to get the contract. So I'm going to call it UniqueNFT.sol. Paste it, and let's go ahead and open the ERC721 utils in GitHub. And let's go ahead and grab the link, just so that our contract here compiles. There we go, and I think we have to adjust the compiler as well. So there we go, we are compiling. And basically, how can we solve the contract? Well, we should check out this ERC721 utils, and in particular, this function that is called. And we see that inside of this function, we're actually making a call to, so to the address 2, which is assumed to maybe have this function on ERC721 received. And excuse me, this 2 in our contract happens to be message.sender. So how can we exploit this? Well, imagine if we actually delegate to our externally owned account, or we delegate our externally owned account to the malicious contract, which could potentially have a function which is called on ERC721 received. And this function inside this malicious contract could actually re-enter. It could call the mint NFT EOA function one more time. And you notice here that this function does not have a reentrancy guard. So we can re-enter it via this function. And because we are an EOA, our tx.origin will still be equal to message.sender. And because we will have yet to mint in our initial call, because we'll still be inside of this, our balance will still be 0. So we will pass this check again. And on top of that, we will increment our token ID. So the token ID will be incremented and that way we'll be able to mint both tokens. So let's go ahead and implement that. And I'm just going to create a contract. I'm going to call it attack. And first of all, here I would like to have a UniqueNFT public, I'll call it target. And I'll have a function which I'm going to call attack. It's going to be external. And also, as we just discussed, I'm going to need to have a function like that. So we're going to need to have a function like this, because once again, the UniqueNFT will call this function from inside the mint NFT. And this is where we will here we will perform the reentrancy. So there we go. And this particular function must return a certain selector. So let's just copy this. So there we go. And let's see, I guess we can make it external. We're not going to be using any of these, so I'm just going to put address, uint 256, and bytes memory. And let's also get this EIP7702 receiver. And I think we don't need the utils here. So yes, this compiles. And now we want to avoid infinite reentrancy, of course. So for that, we're just going to have a Boolean variable called minted. And here inside of our on EIP7702 received, we're going to just say if not minted. So if we have not minted, we will go ahead and set minted to true. And then we will perform the reentrancy. So we will do target dot mint NFT EOA. And so this way we will only perform the reentrancy one time. And of course, we're going to do the same thing in our attack contract. We're going to do this target.mint NFT EOA. And just to be sure, let's do a require. So after we have called this, made this attack with the reentrancy, let's just require that target dot balance of, and we're going to do address of this, because address of this is going to be the EOA. So we'll require this to be 2. So we want to have 2 tokens at this stage. Now a little something that I must say here is that remember that you have to be very careful when you deal with storage variables and account delegation. So these storage variables, they are going to live inside of your EOA. They're not going to be inside the contract. So we will be delegating our externally owned account to this contract, but the storage is still going to be your EOA storage. And right now, at this point, I don't actually know that, for example, minted is false. And so here, and also I don't know if target is initiated or not. So basically here I should initiate them. So I'm just going to receive an address target here, and I'm going to do target is equal to unique NFT target, and I'm going to do minted is equal to false. So this is just a bit of housekeeping because I may have done this challenge previously and I might still have minted true in the storage of my externally owned account. And yeah, so and here again, if we pass this check, if we are able to call the attack contract, then we're pretty sure that everything worked. And yeah, so I think that's about it. So let me just compile this contract. And I'm going to switch to Sepolia. And I'm going to deploy this attack contract in Sepolia. And while it's doing that, I am going to open a terminal. And I'm just going to make a new directory. And I'm going to open a little VS Code. And as well as a terminal. And let's just have a .env. So the first thing we want to do is that we want to delegate. So I think we want to do cast send, so something like that. But I would like to have a private key. And I also want to use a Sepolia URL. So here I will put the value of my variables, so feel free to do the same on your end. So once that is done, I'm just going to, first of all, make sure to do a source env so that my environment variables are basically initialized. And here, so I don't want to send to the 0 value, but I actually want, let's see, so we have deployed our attack contract. So this is our attack contract. I'm going to copy address here, the one that we just deployed. So we're going to perform the delegation. This should take a few seconds. And there we go. So we have now delegated, and right now all we need to do is that we need to call the attack function. So cast send, and I think I have it here in my memory. So the command will look something like this. So here we're going to be sending to our EOA. We're going to be sending the attack address. So remember, this is the attack address target. So we just need to put the correct instance address. So this is my instance address. So let me just put the correct instance here. And let's press enter. And everything seems to be working. Remember, we have a require statement in our attack function, at the end of our attack function. So basically, right, and that require statement makes sure that we have 2 NFTs. And yeah, so we can basically, just to double check, we can perhaps even call a little await contract balance off player .toString, and we see that the value is 2. So we should be good to go, and we can submit the instance, confirm, and make sure that the challenge is solved. So there you go. This was not a very hard challenge, but I think it was still interesting, and it's still a good experience on how you can use certain vulnerabilities that arise from the account delegation. And before we move on, let me just basically cast send. So it's always a good idea to, at the end of your challenge, to make sure that your account is not pointing, your EOA is not pointing to any smart contract anymore. So I'm just going to reinitialize it so that, yeah, we have a clean slate for all upcoming problems. So Thank you very much for watching, and I'll see you next time.